Okay, last time we have talked about how to calculate variance and standard deviation of ungrouped data that does not involve frequency. And that was what we did last time. And then now we're going to look at how to calculate variance and standard deviation of ungrouped data involving frequency. Okay, and thereafter we're going to also look at how to calculate variance and standard deviation of the grouped data. Now, there are steps just like we normally do. There are steps that must be followed in calculating variance and standard deviation of an ungrouped data involving frequency. The steps are as follows. Step 1. Determine the inclusive range. Determine the inclusive range. Now in our last class we have talked about the range. Now the inclusive range and the range is almost the same. The difference is that in the inclusive range you add +1. That +1 is a constant that is usually there in the formula. So instead of highest score minus lowest score, you have highest score minus lowest score +1. And so determine either the range or the inclusive range. The purpose of this is to find out if the data should be grouped or ungrouped. If the difference between the highest score and the lowest score, which is the range or the inclusive range, is up to 15 and above, then that data is to be grouped. If it is less than 15, of course that's the principle, that data is to be ungrouped. Then step 2, form 4 columns. Form 4 columns. Step 3, in column 1, arrange scores in either ascending or descending order of magnitude. Step 4, in column 2, determine frequency and sum. Of course, you know that's a principle. Scores in the frequency column must be added together. Step 5, in column 3, determine the product of score and frequency. That's fx and sum. And then step 6, in column 4, multiply score s with fx to obtain sum of fs squared. Please take that again. In column 4, multiply score, which is s. S stands for score, with fx. And then what you have is sum of fx squared. And then step 7, determine the variance using the formula sum of fs squared minus sum of fx squared over n all over n minus 1. Step 8, determine the standard deviation using the formula. Of course, once you have obtained the variance, the standard deviation s is usually the square root of variance. And then there's an example here. Calculate the variance and standard deviation of the following scores. The scores are here: 4, 4, 6, 6, 6, 6, 8, 8, 8, 5, 5, 3, 3, 3, 3, 7, 7, 7, 7, 7, 9, 9, 10, 10, and 10, 3, 10. And then, like we have just laid out the steps, the first thing is to determine the inclusive range. The inclusive range talk about highest score minus lowest score +1. And when you do that, it will give you 8. And 8 is less than 15. So this data is to be ungrouped. Now remember that in this distribution, 3 appeared 4 times. 1, 2, 3, 4. 4 appeared twice. 1, 2. 5 appeared twice. 1, 2. 6 appeared 4 times. 1, 2, 3, 4. 7 appeared 5 times. 1, 2, 3, 4, 5. 7 appeared 5 times. We have noted that. 8 appeared thrice. 1, 2, 3. 3 times. 9 appeared twice. 1 and 2. And then 10 appeared 3 times. 1, 2, and 3. And so when you add that together, it's going to give you 25. And then to obtain fx, this notation talk about product of x and f, meaning multiply the first column by the second column. And then 3 times 4 will give you 12, 4 times 2 will give you 8, 5 times 2, 10, 6 times 4, 24, 7 times 5, 35, 8 times 3, 24, 9 times 2, 18, 10 times 3, 30. And if you add it together, it is going to give you 161. Now, the last column, to obtain the last column, you multiply x again by fx. Please, not f again. X and fx. X, that's the first column, and the third column. X and fx, such that 3 times 12 will give you 36. 4 times 8 will give you 32. 5 times 10, 50. 6 times 24 will give you 144. 7 times 35 will give you 245. 8 times 24, 192. 9 times 18 will give you 162. 10 times 30 will give you 300. And if you add it together, it's going to be 1161. Now you apply the formula. See the formula here in step 7. Step 7, we have identified the formula. You apply that formula. Now sum of fx is 1161. Fx, sum of fx is 161 all over 25, all over 25 minus 1. And you can see it there. And so you square, since it is there in the formula, you square this 161, square it first. Remember to square it first before you divide by 25. And then when you do that, it's going to give you 1161 minus 1036.84 all over 24. This 24 is n minus 1. N is 25 minus 1 is 24. That's how you get this 24. And then when you subtract it, 1161 minus 1036.84 is going to give you 124.16. Divided by 24, you have 5.17. And when you obtain that, this is the variance of the distribution. Now, the standard deviation, which is x, is just the square root of variance. And that square root, if you find the square root of 5.17 as it is going to give you 2.27. This shows the extent of variability in this course we have used in the example. Now, that is for calculation of variance and standard deviation involving frequency. Now, the next one is to calculate variance and standard deviation of grouped data. Grouped data. All the formula we have used is called the Roscoe method. All the formula we have been using how to calculate variance and standard deviation, that formula is called Roscoe method. I've told us there are different methods. Even in this Roscoe method, there are different variants of it. There are different variants, but this one seems to be the easiest to use. There is a mean deviation method, I mentioned it earlier, and the coding method. Now, to calculate variance and standard deviation of group data using Roscoe method, there are also steps to follow. Step 1 is to determine the inclusive range, and then step 2 to form 5 columns, and then step 3 in column 1 arrange class intervals, and step 4 in column 2 determine frequency and sum. Step 5 determine class mark in column 3. Step 6 determine sum of fx in column 4 and sum. Step 7 determine sum of fs squared in column 5. That is multiply class mark by sum of fx and sum to obtain sum of fs squared. Step 8 determine variance using the formula. The formula is that variance is equal to n into sum of fs squared minus sum of fs squared all over n squared. That's the formula. And then step 9, determine standard deviation using the formula. Standard deviation equals to square root of variance. Now, there's an example here to portray what we have done there. There's an example. Calculate the variance of standard deviation of these scores. 8, 5, 10, 21, 19, 18, 15, 14, 16, 7, 6, 9, 11, 12, 13, 14, 15, 16, 15, 14, 13, 16, 14, 18, 19, 14, 20, 15, 14, 13, 14, 15, 13. Now, if you look at that distribution, the highest score in that distribution appears to be 21. The highest score is 21. You can see 21 here is the fourth score in the distribution, 21. While the lowest score in that distribution appears to be 5. The second score in this distribution. And so the inclusive range is 21 minus 5 plus 1, which will give 17. And of course, you know that 17 is greater than 15, meaning that this data is to be grouped. After that, you form the 5 columns. Form 5 columns. And in column 1, arrange class intervals. You form the class interval by first deciding what should be the class size. Now, when we talk about class size, we talk about number of scores contained in each class interval. And that's the class size. Now, for this example, we are choosing 5 to 7, meaning that each of these class intervals consists of 3 scores. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Please don't indicate the class interval by just the class boundary. Say 5 and 7, you not count it. No. There are 3 scores in each of them. So the class size, the class intervals have been formed using class size of 3. Now the next one is to determine the frequency. Frequency simply talk about how many times scores in the class interval occur in the distribution. Now, you can see that here is F or N, so that you will not get confused. It's the same thing. F, frequency, and talk about total number of scores in the distribution. Now, scores between 5 and 7 appear 3 times. Scores between 8 to 10 appear 3 times also. Scores between 11 and 13 appear 6 times. Scores between 14 and 16 appear 15 times. Scores between 17 and 19 appear 4 times. While scores between 20 to 21 appear there twice. If you add that together, it's going to give you 33. And so the frequency is 33, or the total number of scores in the distribution, which is N, 33. Now, the next thing in column 3 is to determine the class mark. The class mark, another name for the class mark is class midpoints. They talk about the scores in the middle at the center of each of the class intervals. Now, you see this class interval 5 to 7. The score separating 5 and 7 is 6. Another way to obtain is to add the lower class boundary to the upper class boundary and dividing by 2. 5 plus 7 will give you 12. 12 divided by 2 will also give you 6. So these are the class mark. Here, for instance, you have 20 plus 22, which is 42. Divided by 2 will give you 21. That's how to obtain the class mark. Okay? The class mark need not be added together. It need not be added together. And the sum of it does not have any relevance for calculating variance and standard deviation. Now the next thing is to calculate the fx. The fx, talk about multiplying column 2 and scores in column 2 and scores in column 3. So that 3 times 6 is 18, 3 times 9 is 27, 6 times 12 is 72, 15 times 15 will give you 225, 4 times 18 will give you 72, and 2 times 21 will give you 42. If you add them together, it's going to give you 4, 5, 6. Now, the last column there, how do you obtain it? By multiplying this class mark, okay, by fx, you will have fs squared. This class mark here is x. When you multiply it by fx, what you have is fs squared. So that 6 times 18 will give you 108, 9 times 27 will give you 243, 12 times 72 will give you 846, 15 times 225 will give you 3375, 18 times 72 will give you 1296, 21 times 42 will give you 882. And when you add it together, you are going to have 6768. That's 6,768. Now, you now apply this formula here. We have talked about this formula before. Use it in obtaining variance. Variance is equal to n into sum of fs squared minus sum of fs squared all over n squared. Now, that n, I've already emphasized it, n here is 33. Okay? Now, the sum of fs squared, that's look at fs squared, is 6,768, and that's what it is here, minus sum of fx squared, that's 456 squared, all over n squared. When you talk about n squared, n is 33. If you square it, it's going to give you 33 times 33. And now when you multiply 33 by 6,768, you have 223,344 minus, if you square 456 by itself, you are going to have 207,936. And then 33 times 33 will give you 1,089. If you subtract 223,344, if you subtract 207,936 from 233,344, you will have 15,408. And if you divide it by 1,089, it's going to give you 14.149. And that is the variance. 14.149 is the variance. And then the standard, the square root of this 14.149, the square root of it, which is the standard deviation. Of course, let's use x to represent standard deviation. We have been using x consistently, so let's maintain x. And even though some textbook is written SD, but for now we're using x. Okay? Now, the square root of that variance, square root of 14.149, will give you 3.76. So while the variance is 14.149, the standard deviation is 3.76. Okay? There is a way the standard deviation is often interpreted alongside the mean. Where you have where the mean is small, and the standard deviation is large. If it is in the classroom setting, it signifies a very poor performance. But if the mean is large and the standard deviation is small, shows a superlative performance, a good performance from the student. So the variance and standard deviation is often interpreted alongside with the mean because it goes the same time with the mean. Just as we said in our previous class, that range goes with mode. Okay, the standard, the variance and standard deviation go with mean. That is why when you are using the mean deviation method, you first determine the mean before you go to determine the variance and standard deviation. Thank you. God bless you. Stay safe. and observe all hygienic practices to avoid the COVID-19. It's real, but it will not be real for you and for members of your family. God bless you.